Okay, we'll go ahead and get started. I just wanted to make sure that I had the recording going. Good evening. My name is Reggie Taylor, and I'm a coordinator of academic success for the Walden University Office of Research and Doctoral Services. And many of you, or some of you, may have attended one of these previous sessions. By showing in the chat, has anyone on the call here been in one of the previous sessions, maybe in the last few weeks here?
Yes.
Okay, great. Fantastic. And we're just going to kind of follow that same sort of pattern. As I mentioned, these were intended to align with the research course, the basic quantitative reasoning course. And then I just started to alter it to different statistical topics and concepts. And so this evening, we're going to discuss one of those statistical concepts. Again, you'll see we won't be doing things in SPSS here tonight, but we're going to be kind of setting the foundation for you. Again, if you are taking the research course, setting the foundation of knowledge for you as you start to go on into the middle and lateral weeks of the course, where you will start running statistical tests. For example, if you've looked ahead at your syllabus, you'll see, you're going to be running correlation tests. You're going to be running t-tests. You're going to be running ANOVAs, and you're going to be running multiple regression, et cetera. And to run those tests, there's some foundational knowledge that is needed. And basically, we're going to talk about that. And there's three concepts called statistical significance, effect size, and confidence intervals. And I'm sure you've probably heard of these terms, somewhere before, but we're going to hopefully reacquaint you with these terms, and so you can understand how what you're getting here tonight is going to prepare you for what's coming in the subsequent weeks. And I believe even in the research course, you have a week or so, I believe we're in that area where you talk about statistical significance and confidence intervals, et cetera. So I'm going to go through a few housekeeping notes, and then we'll talk about anxiety. And then you'll note that for individuals in the PhD program, if you were to look at your dissertation rubric, you'll see that you have a section in there called the data analysis plan. And in that data analysis plan, in your proposal, you'll be writing about statistical significance. You'll be writing about effect size, and you'll be writing about confidence intervals. Now, not only that, but you may be reading a journal article. As I mentioned, someone may be on the call here that's not taking the course, but you may be reading a journal article, and you undoubtedly will read journal articles when you're doing your dissertation, quantitative ones, qualitative ones, regardless of what you're doing. And these terms and concepts are going to be in those articles that you read, and those authors are going to report their statistical significance, effect size, and confidence intervals. They may, because we'll talk about the importance of reporting all of this, because most people really think the most important thing to do and that they've hit the jackpot when they say that they found a statistically significant result. And they really don't talk about effect size and confidence intervals. And you'll see through this session here that without combining these things and talking about them collectively, you really are not presenting meaningful results. In other words, statistical significance in itself is meaningless. But we'll understand what needs to accompany us saying we had significant results. Does that make sense to everybody?
Yeah.
Okay, fantastic. And start thinking about as we go through this, and just start thinking, I looked at an article and I remember seeing this, I remember saying that, and now perhaps, I understand, a little better what it is that that I'm looking at and how to interpret and understand it. Now, This is going to be about an hour session, a little shorter tonight, and it's being recorded. And you'll be able to get the recording probably the quickest at the YouTube site here. And then sometime tomorrow, hopefully, it will be on the ORID's website. Just make sure that we keep our lines muted so that we have a safe, friendly, and non-intimidating learning experience for all. And again, this is not a general statistics seminar or a complaint seminar. So let's focus on the abstract. You'll see that when we start talking about p-values and you start looking in your statistics textbooks, they get very, very complicated, and you have to read stuff over and over. And what does this really mean? And you think you have it, then you pick up another text and you read it, and you're like, no, I don't, I got it. And so we're going to just really try to focus at a very broad level here right now. Okay, so that you just get a good understanding of what statistics is about and what writing results are about. Okay, and I think this will all make sense as we progress through the presentation. Okay. Now, as we mentioned, and I mentioned in all my sessions, the main thing is you're not going to walk away from here an expert in statistics. You're not going to be an expert in p-values, effect sizes, or anything, confidence intervals. But the whole idea is for you to have your anxiety lowered. When you look at your application assignment or a discussion, and it's asking you something about confidence intervals or effect sizes, or statistical significance, you have now some foundational understanding of what you're being asked. And when you have that and you look at that discussion or that application and you're like, okay, I think I can do this, that anxiety tends to go down, okay? And when we lower that anxiety, we have more cognitive energy to focus on during our application assignment. And as I mentioned to many of you, this is my primary goal, not for you to come away, matter of fact, remembering anything tonight, but more so having that lowered anxiety, okay? And that appears to have been working for us so far. Now, in a dissertation in chapter 3, you're going to have something called a data analysis plan. But also when you're taking a statistical course, you're going to be discussing these concepts. And the whole idea is to be able to go back to your course and say, okay, I remember studying these concepts, and now I'm able to translate these concepts and apply them to my data analysis plan. A lot of times when we look at a rubric, we'll just see the terms and we don't quite understand what is it that we're supposed to be writing to? What do they mean by that? What am I supposed to do? What do I need to understand? And that's what we're going to try to come away with here this evening. Now, statistical significance. If I ask you what that is, everyone would probably say, oh, p-value is less than 0.05. And we're not going to delve deep into p-values, but that's what you would probably associate with research. When you read an article, you would probably look to see if the author said the results were statistically significant. And at that point, you may say, oh, I've read enough and I know what I need to know, and move on and attempt to critically analyze or synthesize that article. But we're going to see that there's much more to that. But what it is that in its global terms, statistical significance is a probability. And I want to emphasize that word probability because you'll see that what I'm going to be talking about is that the p-value is really nothing but a mathematical probability. It really has nothing to do with your study. It doesn't tell you anything about perhaps your variables, you're really just going to be looking at a number. And I'm going to talk about that a little bit more. But it's the probability of achieving a significant result. And that result, of course, where the p-value is less than or equal to 0.05. And that means that it wasn't due to chance. And what do we mean by chance? And this is what we want to understand. We must think that anytime we do research, the best thing that we can do is random sample. Okay, I've got a population of people. I'm going to go in and get a sample of 100 of them randomly. And ideally, I should come out with a nice normal distribution. Recall, some of you, that we talked about descriptive statistics, and we talked about that normal distribution where a certain amount of people will fall within one range, and et cetera. that's kind of what would happen, what we would expect to happen with the random sample. And let's just say that we want a random sample Walden University's PhD students, their GPA, and 30,000, 40,000 plus students. We know it's not feasible to try to catch up with all of those individuals for research purposes. So we'll get a sample and we'll see what the GPA, let's say the average GPA is. But ideally, we should get, those in the middle, those few achievers high achievers on the end, and those low achievers on the other end. But isn't it possible? Isn't it a chance if we're random sampling? It's not likely, but isn't it a chance that that random sample just happened to pull everybody with low GPA scores? Does that seem possible to you? Isn't it a chance?
No. Yes, I don't know.
I think it's a possibility because if you're evaluating it and you want to get the probability of it, it's a chance.
It's a very small possibility. Yes, it is. And that's what we want to make sure that whatever we come up with, we didn't have that small chance occurrence. For example, let's talk about the lottery. You know that when those lottery balls come out and you look on the news and those numbers somehow appear to be kind of, excuse me, evenly spread. You're going to have a number between, say 1 and 9. You're going to have something between 10 and, it's going to kind of be evenly spread up to about like, whatever the highest number is. Random pulling those numbers. Isn't it possible, not likely, but isn't it possible that those 5 balls could come out of there as 1, 2, 3, 4, 5? It's possible. Highly unlikely, but very possible. So what we're saying is the results that we get are not due to that chance occurrence. Does that make sense to everybody?
Yes.
Okay. Now, but then we say, okay, we're going to evaluate it. P is 0.05. What does that mean? Where does it come from? It's an arbitrary value. And where did it come from? It came from Sir Ronald Fisher. At the time, Sir Ronald Fisher is considered the father of modern day statistics. Excuse me, pretty much anything Ronald Fisher said, anything Ronald Fisher published, was pretty much Bible. And Ronald Fisher said that, the probability of achieving this result, blah, blah, blah. And I'm going to be comfortable, 5 out of times if that was to happen. But if it happens more than that, then we need to look a little further. So let's not look too much more into this, but it basically, that number came from Ronald Fisher. Ronald Fisher could have said the p-value is 0.01. That's what we'd be using today. Ronald Fisher could have said the p-value is going to be 0.10. That's what we'd be using today. But now, what is this p-value? And how, when we look at SPSS output, and we look for the p-value for this statistical test, that's the first thing you're going to look for when you get output to see that you get that significant result. That number, where does it come from? Well, it's based on something called critical values, and I'm going to talk about that, and it's going to make sense when you see this. And those critical values, based on like the statistical test that you're going to run, something called degrees of freedom, and even the alpha level that we select. We conventionally select 0.05. So based on this information, a critical value is calculated behind the scenes. You have nothing to do with this. And when you run your results of your test, it's going to calculate a value that you evaluate against this critical value. And we'll talk about this. And basically, it's a comparison. to make it simple, let's just say the critical value is 5 for your test. If once you run your test, if the critical value comes out at 6, it was higher than 5, it means it's a statistically significant result. But it tells you really nothing about that research question, those variables that you're talking about. What does that mean in terms of size or things like that? You don't get meaning yet, but you do know that I do need to look further because there's more information that's going to be much more meaningful than the p-value. So what I'm saying is that anybody here that writes the results, you will present more than the p-value, okay? Does that make sense to everybody? If you just write the p-value, you're not going to have a complete write-up. Does everybody understand that? But we'll talk about what else we need to do. Now, having said that, this is what Fisher said. Now, I'm not going to read this to you. I'm going to let you use the presentation. But again, he said it is an arbitrary, but a conventional level for the practical investigator, okay, et cetera, et cetera. But he says, but he had to choose a number. The cutoff had to be determined, and 0.05, look at that, looks rather decisive to the human eye. So it really wasn't a lot of science behind this. It was just Ronald Fisher was leading the charge at the time, and this is where we ended up at. So in other words, is there really a difference between a p-value of 0.049, which is significant, and one that's 0.051, which is not significant? Less than 2/100ths of a point. You see that, and that's what Fisher is saying there. I mean, we need more information. We could take one data point out of the data set and rerun the analysis and probably get a different result, okay? So again, that's how we got to 0.05. And that's a historical lesson, but I think is one that every doctoral student should have an understanding of how and why we got to 0.05. Make sense to everybody? We feel good about that?
Yep.
You'll never have to worry about calculating that and the mathematics behind that because we're not mathematical statisticians. We just need to understand conceptually what that means when we look at it and knowing where it comes from. Okay, now, I'm going to show you where it comes from. Have you ever looked in the back of any statistics textbook and you've seen those, what they call tables of critical values, just tables full of rows and numbers? Has everybody ever seen that in the back of a textbook? As a matter of fact, if you look at your Warner text for the quantitative course, you'll look in the back in the appendix and you'll see tables of critical values. This is where that critical value comes from. Now let's talk about this table. Excuse me. Now the one I'm going to show you here is called a t-distribution. And this would be if you're running a t-test. And don't worry about that if you're not quite sure what a t-test is. You'll know in a few weeks. But if you're going to run that t-test, and we're going to use the alpha level of 0.05 that we want to judge significance at, right? Everybody with me so far? Now, remember I said the degrees of freedom, DF has something to do with it? Well, these degrees of freedom has something to do with the sample size, okay? And it's usually n-1, so the sample minus 1. So you see these tables will get larger. So say you had, 200, records, a sample of 200. Well, the degrees of freedom number here, or the critical value, would change, obviously, and it continues to get basically lower, as we get more of a sample. So for example, let's just say it was a sample of just 4 people, which we know is not the case. You would want more than that. So the degrees of freedom would be 3, n-1. We're looking at an alpha level of 0.05. The critical value, before you even put data in, before you even write your proposal up, but if you know this is what you're going to do, behind the scenes, when you press the SPSS button, you have to get a critical value greater than 3.182. If you do, SPSS is going to say p-value is less than 0.05. Does that make sense to everybody? Again, you don't know what this value is, but SPSS knows. But with your data, once you press the button, it's going to calculate. So we're basically comparing this value here, 3.182, to the value that will be calculated with your data set. Does that make sense? And if the value with your data set that you're going to be using is higher, say, than 3.182, you have a significant result. Okay? Everybody okay with that? Again, this is conceptualization because this critical value will change depending on your research. Okay? Now, so let's say that we are going to run research. And I found this slide that I thought would be helpful. And let me explain to you what this is. Now, don't worry about this. It looks a bit confusing, but this is a power analysis, and this is some software that you will use when you have to calculate your required sample size. But don't worry about that, okay? But what I want you to see is before the study has even been run, we go in here and we try to figure out the sample size. So in this particular case, it says the total sample size is going to be 128. Remember that number, 128. And if you were to look at that table that I showed you, remember the table for the critical values, you'll see what value that leads to in terms of degrees of freedom. So it would be 127 degrees of freedom. But look at what happens up here. You see the critical T? It lets us know that now to have a significant result for a t-test right here, you see, degrees of freedom is 126. So that's n minus 2. So you see the total sample. So it knows, and you're going to put it in here, and you see it lets us know. So now when we run the results right here, the T critical is 1.979. So when you run your t-test, your calculated t-value must be greater than 1.972. That should be a 9 for significance. Does everybody understand that? And if that happens, again, behind the scenes, SPSS spits out P less than or equal to 0.05. Does everybody see that? That's what happens behind the scenes. But when you see that P is less than 0.05 or greater than whatever, I want you to understand what has happened there. Does everybody, is it okay to move on at this point? I want to make sure. You can just put in the chat there. Everybody good? Okay, great. Now, again, remember, you're not statisticians. You don't have to worry about calculating any of this. The software does it for you, okay? But now, so let's move on now. So here's just an example, and don't worry about this because you will be doing this in a few weeks. This will all make sense to you. But let's just say we ran the test and the t-value, 126, that just lets me know the degrees of freedom. But the t statistic that was calculated was 3.453. That means that what happens? That's a significant result, and that results in a P that equals this, and that's less than 0.05. Remember, you're not going to be calculating any of this, but as you know, when we do these sessions, what I want you to be able is to look at something and understand and be able to talk about what you are seeing, okay? So, but don't worry about this, but we know that if I were to say, what's going on here, you would say, this test was run and the T critical value had to be exceeded and for it to be a significant result. And so obviously, if this was exceeded, this is significant. And so you understand that, but that is not enough. You must report more information for your results to be meaningful. You never stop at P equals this, and that's the end of the story. If you read a journal article and they just say the results were significant or not significant, and they give you the p-value and they stop there, that's critical analysis and synthesis. That's a critique of that study. You really don't know a whole lot. You don't have all the information you need to make a well-informed decision about that article that you read. So what else is it must we provide? The next piece of information that must be provided is something called the effect size. Has anyone heard of the term effect size before? Okay, well, let's learn a little bit more about it. Now, let's just say we were doing a study and we were looking to see if there was a difference in something. Okay, we're all online learners. Let's just say we were going to compare online learners against brick and mortar learners, all PhD students. So we wanted to see if one group or the other group had higher overall GPA scores. Okay, makes sense? Now, suppose after we ran that test, we put all the data, we got a p-value less than 0.05, meaning that there is a significant difference. But that's all we know. The effect size now is going to let us know something about the magnitude of that difference, the size of the difference. How much higher was the online learner's GPA on average than the brick and mortar learner, or vice versa? You see that? We're starting to get more information now. And really now we're starting to talk about our particular research. Does that make sense? Fantastic. And now the effect sizes, they vary by statistical tests, and we'll look at that. But what you get is what we call practical implications versus statistical implications. The p-value is a statistical implication, pure mathematics going on behind the scene, and says if a number comes up higher than this number, you tell the reader it's a significant result. And that's all that tells us. But now, basically, how significant was it? How large was the difference? Or let's just say we were looking at the relationship between two variables, the relationship between attending these sessions in your grades in your quantitative course. Perhaps the more you attend the sessions, the higher your grades, etc. Well, suppose we got a significant relationship. Well, how large was that relationship? You know, what was the direction of that relationship? That's what we're talking about with effect sizes, and that gives us practical implications or meaningful results. And if I'm correct, in your upcoming or one of your assignments or discussions, you have to talk about meaningful results. Am I correct? Has anyone seen that somewhere coming up? You're going to be talking about meaningful results. And what I want you to understand from that is that you're going to go beyond the p-value, and now you're going to talk about effect sizes in addition to p-values. Are we good? Fantastic. Now, let's make that logical progression again. Now, remember, before we wrote the results up, remember this was the critical value that we needed to exceed, and we exceeded it, and so we said the results were significant. But now, we must report the effect size. So remember in the previous slide, we stopped here at p equals 0.003. Now we're going to talk about the magnitude of the difference. How large was the difference? And one of the basic effect size measures, and we'll talk about that a little bit later, is something called Cohen's d, and you've probably heard of that. Okay. So when you pretty much run a t-test where you compare two groups, Cohen's d is the appropriate effect size. Now this one says Cohen's d is 0.37. So now what does that mean to the reader? How, when you read a journal article now, you make sense of that? This gives you a lot more information. But I'm going to go back to the previous slide. And for those of you, remember, those of you that attended the descriptive statistics session, remember we talked about standard deviations? You know, when we describe the data, we have an average score for data, but we also know how far on average each score deviated from that average. Remember we talked about standard deviations? Well, an effect size is measured in standard deviations. So let's make sense of this now. So if I have Cohen's d is 0.37, what that means is that that is 0.37 of one standard deviation, okay? That's what that means. So let's just say, let's make the numbers easy. Let's just say that the standard deviation was 1. In other words, let's say the average score was 5 out of 100 people. But the difference is the average difference that each score was from, say, the average score was 1 point, 1 whole point. That's the standard deviation. Well, the difference now is measured in terms of that's 0.37 or 337 hundredths out of, you know, out of 1 point. Let's just say, to make it easy, that was 0.5. That would be half of a standard deviation. Does that make sense to everybody? So that's why it's important to understand these concepts when we're going in this logical and progressive order. So we know what a standard deviation is, okay? Now, if the average score differs by, say, 10 points, and that's the standard deviation, and the Cohen's d is 0.5, that's half. So half of 10 would be 5. So the mean difference is about 5 points. Now you see how, depending on what you're researching, how now it's starting to make more sense to you now. You're starting to now talk about differences of the particular variables and data versus this statistical number here. You see the difference now, how meaningful this can be? Does that make sense to everybody? Now, again, remember, you're going to learn more about effect sizes, but this is conceptual. In other words, you never write results without reporting effect sizes. Okay? Now, I did see there's a question there. So does effect size only come into play with 2 or more variables? No, you will report effect size anytime you run a statistical analysis. 2 variables, 100 variables, 5 variables, etc. Okay. But now I'm saying we must go even further. So the results were significant. Measure of effect was 0.37. But what else are you asking for, Dr. Taylor? What I'm asking for now is, because we're never 100% sure. Remember, we're talking probabilities. Well, have we ever heard of margins of error when we look at the polls about voting and they say this candidate is up by 14 percentage points, plus or minus 3 points? Have you heard of something like that before? Plus or minus? That is what we call, excuse me, let me go through this first here. This slide here just gives you an example of some effect sizes for different tests. And you're going to be running a multiple linear regression test in your course, or you're going to read an article about regression. Well, that author should have reported the R-squared for that test, and so on and so forth, okay? So this is just a little helpful table here that you can use. But as I was saying, give me a second. But now, the next thing is that the confidence intervals, and you all have heard the term 95% confidence intervals. You always want to run 95% confidence intervals and report those also, because now that's going to give you a little bit more information. So It's basically a range of values above and below. It's a range where that true value in the population is likely to lie with 95% confidence. Now, the part that's confusing is that what do we say? What do we mean when we say 95% confidence? And I told people, okay, put that in terms that I can understand. And they just keep saying, I'm 95% sure. I'm 95% sure. I'm like, but what does that mean? Well, what that means is that let's say that you have a data set and you pull a random sample out of the data set. And you want to say calculate the average or something. And you get an average. You go back in the data set, you pull a second sample and you see what the average is. You go into the data set a third time, you pull a random sample. What this 95% means is it's a concept that if you were to do that 100 times with the same data set now and go in and do a random sample, that whatever that point estimate is, that average or whatever you are calculating, say the difference between, group A and group B, that 95 out of 100 times, that true point estimate, that mean or that average or that difference is going to have a lower point and an upper point. So for example, let's just say Walden or online learners against brick and mortar learners. And we see that there's a significant difference in GPA, a mean difference. This is the average score, that mean difference. Okay. What we're saying is that if we did the study again with a random sample, but again, 100 times, that mean difference is going to probably more than likely be somewhere between here and here in the true population if I were to do this with the whole population. Does that make sense to everybody? So it's a concept of repeating a study, say 100 times, and then if you plotted the average 100 times, you know it's going to go up and down here and there. And it's going to be a high range and a low range. Now let's look at this in another little slide. I tried to do this the best way I could. I'm not a good artist, so please bear with me. So again, here's where we're saying here, don't worry about this. The results are significant. It was a t-test. This was that calculated critical value that was compared against something, and it resulted in the p being less than 0.05, and we know that was significant. We know that the difference was a 0.37 points of a standard deviation. And again, that's kind of like what Cohen calls a medium effect size. But now the 95% confidence interval for that difference, 1.15. Now the 1.15 is this red arrow. This is the average mean difference right here. Out of 100 times, say this is the difference. But now, I got an average at low as this, 0.45, and I got one as high as 0.25. So somewhere, if I took the entire population and did that test, I can tell you that 95 out of 100 times that true difference is between 0.45 points and 2.5 points. Does that make sense to everybody? So now we have a lot more information. We know it's significant. We know the measure of effect, how different it was. And we know the range of the difference if we were to do this test multiple times. This is what we call meaningful results. Does that make sense to everybody? Now, when you start looking at journal articles, I want you to now challenge yourself. And when those authors report those results, start asking yourself, do you see where they reported the effect size? What were the confidence intervals? With that information, you now are starting to be able to critically analyze and synthesize literature. Does that make sense? You don't just regurgitate literature back. Oh, the question was this, they did this. Okay, what does all this mean now into the context of your literature? Does this make sense to you? This is why we're looking at literature reviews, and this is why it's important for us to understand when we get to this methodology and the statistical results that we understand that too, because that's where we put the meaning to all those other 15 pages of the article we just read. Does that make sense to everybody? This is where the meat of the matter is here. And in this one sentence here, you get a wealth of information. Okay, does that make sense? Now, so things that you want to look at, does that effect size confirm statistical significance? Now, what do I mean by that? It also helps support significance. Now, notice that when we make a hypothesis, we say there is no difference between group A and group B, meaning that the true null value here, this is kind of like a null value, no difference. We won't be on this side, we won't be on this side, kind of, there's going to be no difference. Now, when we run confidence intervals, note that this confidence interval here, and please make point of this. Notice this confidence interval does not span zero. It does not include the zero range, meaning that there is not a null difference. I mean, there is a difference. There's a deviation from zero. Does that make sense? So when you see confidence intervals, they will not span zero, because you actually are saying, is there a significant difference in the confidence intervals? Does it span this 0 point here? So if I had a point here in the confidence interval and it came over like that, that does not confirm statistical significance. So it's even also helping confirm significance, but also giving more meaning to significance in terms of some numbers, depending on what you're measuring. Okay? Now, so then you ask yourself, what does it mean? And we know that this is a measure of magnitude, right? And it's measured in terms of standard deviation. Now, a good thing to do is that when you look at a study and you get a medium effect size, is that consistent with like literature? What are you seeing in the literature, the like literature? Is this a significant deviation in the effect size here? Why might that be? Do you understand now how, with this methodological understanding, how you will look at and read an article differently now? I'm hoping, yes, no? And what you really are looking for? You have to have that methodological piece to back up also, the narrative piece, and understand really what that article is saying. And again, what does it mean in the context of your research? So you're researching a topic, you're pulling articles on that topic, you're looking at the results, you're seeing what the effect sizes were significant results, and you got to make some meaning of that in the context of your research. This information that you see here is going to help you make an hypothesis. If you continue to see significant results using certain variables, you say, well, that's what I'm going to see. And then that's when you make that comparison, to the like literature. Does this make sense here now in terms of a broader research? And notice we're not calculating, we're not pressing SPSS buttons, but we're really understanding conceptually what we're doing as we move on and what it means for meaningful results. Okay, fantastic. And no, the mean difference is not the same as you said SS. I'm assuming you're meaning sum of squares or something, but no, that's something different. Now, another thing to ask yourself, is this a large or small confidence interval? Suppose this confidence interval went from 0.45. Let me try to draw a little bit. Suppose the confidence interval went here, like that. What would that mean to you? Versus from here to here. To me, that means a lot more uncertainty, right? A lot more uncertainty, yes. And if you had a larger sample size, that's a great point. A larger sample size will probably yield you a larger confidence interval. Not necessarily do you need one, but it will yield you one. But again, notice if you're talking about your research and you're saying now the possible range is from 0.20 all the way up to like 4.8. So I'm saying the GPA score difference could be just about anything. Perhaps not, I mean, and then so what does that mean in terms of your research? I don't know. But if it's a nice tight confidence interval, what does that mean? This is the way I want you to start thinking. Does that make sense to everybody? Now, again, resources. Here's the ORD's website where you'll see the previous sessions that have been done, and the recording will be here hopefully sometime tomorrow. Hopefully by tonight, the recording will be here at the YouTube site. But I wanted to do one other thing here, if I could. I was pulling down some things from the web, and I saw some things that I thought might help with understanding, if I can find it. Degrees of freedom, p-value problems. I was actually looking for, they had a nice graphic in here that just kind of showed, okay, I can't find it. But anyway, yeah, it's just a graph that showed where an individual had took a bunch of samples and just showed that for each sample, I can almost kind of replicate that. Let me try to do that. And what they did was, it's just kind of like, each study, what they did was they showed where the upper point was and the lower point. And this was with one sample, okay? Then it was another sample and the confidence intervals were like that. And another one, it was like that. And then another sample, they showed that, and they were showing something like this. So each one of these is a different sample taken from the same data set, and they were plotting it. And what you would see from something like this is that now the lower limit would be right here, whatever that was, and the upper limit, I'm gonna just draw this up, would be right here. So does everybody see that now again, and how that's kind of re-explaining? So basically, whatever this lower point was here and this higher point here, would be the 95% confidence interval. So if it was 95 lines in here, 95 different samples, excuse me, forget that last one there. But if it was 95 different samples, you see the point I'm trying to make there? That what I can say with some confidence is that the true mean is somewhere between here and here. Does that make sense to everybody? Because when you're briefing results, you never know for sure. And you have to tell someone, what is that range of possibilities? In other words, suppose someone is a decision maker and needs this information to make a decision. Okay, what are my range of possibilities? How confident are we in that? That's what good statistical analysis can do, for someone. So does that make sense to everybody here? And this whole confidence interval connection thing makes sense now. And again, I always encourage you, please go out here to this seminar questionnaire and let me know what you think about these sessions. And again, what we've done here was kind of focus on what's called the data analysis plan, that if you are contemplating writing a quantitative study, that in that plan, you're going to be reporting results. And you're going to be telling us what statistical significance is, how you're going to assess it, what the effect size is, how you assess that, and confidence intervals, and how you assess that, okay? And you know the resources, where those are available, and where the survey is. So again, I see someone has posted something in the chat, a visualization tool, and those are good, those visualization tools that help you see how confidence intervals change. But the idea, again, if I was to summarize, I want to say is that as you move on and start reading articles, okay, you now want to start making sure that this information was included in the results so that it makes sense to you. If not, this is something that you critique. You may say, I read an article by such and such, and however, they reported significant results, but, there wasn't a measure of effect size reported, or if it is, effect size reported and confidence intervals, make sense of that. You're discussing this literature in the context of what you're doing. You're not just reading an article and regurgitating what you just read. Does that make sense? Even though I know we're not talking about literature reviews, but it is a connection with understanding the statistics and how to master your way through a literature review. Does that make sense to everyone? Okay, I will take that as a yes.
Yes.
Okay, so great. So that's all that I have for you this afternoon here. And just remember now, as you save this presentation and the recording, because as you go on through the weeks and start reporting on your statistical test, you are going to be reporting statistical significance, effect size, and confidence intervals in those results. And that's going to ensure that you have really covered the basics and really maximize your grade, but also more important, understand and get a good understanding of statistics. And you'll notice here, we didn't calculate anything. You're not worried about mathematics. You're worried about understanding and applying it. And I'll do one other thing here to show you just how simple this will be when you go. I believe if you have to calculate confidence intervals for a particular application, let's take a quick look at something like that. Give me just a second. This version 29 is very, very slow. It eats up a lot of energy, but it will open up in just a second. Open, yeah, here we go. Now you see, for example, now for individuals that may have been in the previous sessions, remember when we ran descriptive statistics, and I believe you have to run some descriptive statistics on a particular variable and report the confidence intervals. So again, this is a data set that I have open. If you don't mind if I go through this, if you have to leave, go ahead. But anyway, here's a data set that I have open. And I have variables of gender, some dissertation anxiety, just some numerical measures. So now I'm going to take a numerical, say, dissertation anxiety, and I'm going to put it over here. But notice now in statistics, you see how it gives me the confidence intervals for the mean. Always make sure that that is selected. And you will then, when you run your report, let's take a look at that. Give it a second here. Okay. You see right here, the 95% confidence interval. So for this variable, you see right here, the average score was 7. Does everybody see that? I want to see some thumbs up or some yeses in there, because this is important. Now, you see the confidence interval?
Yes.
You see, it could be as low as 6.4 and as high as 7.6 in the true population if we were to run the study 100 times. Or let's just say 10 times, and we would say about 9 times out of 10, that true mean in the true population. Remember, we're getting this from a sample, but we are going to infer the results to the broader population. So what we're saying here is that in the population, which we cannot sample them all, but that value will be 6.4 at the lowest, 7.6 at the highest. Does that make sense to everybody now of how to run that and understand what the 95% confidence interval means? Okay, everybody good with that? It's as simple as that. Fantastic. But now we also go back, we know the history of p-values and quite a bit now to give us that foundation. And I guarantee you now, as you start reading further about the statistical tests and things and hypothesis testing, all of this stuff's going to start making sense now. And before we close, and what should happen is we go from here to here. Have we done that? I guess not, huh? A little better, huh? Okay, fantastic. And that's it, ease. We didn't say eliminate. We said ease, and that's where we're trying to go. But I'll guarantee you now, if you go and look at any discussion, application that you have to do, or if you're not in the course and look at a journal article now, I'll guarantee you, you have a better sense of what you're looking at now. I'll guarantee that. Wouldn't you say so yourself?
Yeah.
All righty. Fantastic. And that sounds like a smile there. Great. Who leads this?
Dr. Taylor.
Yes.
So my understanding of confidence interval, especially 95% confidence interval, is if you run a study, you try to capture. If you said if you run it many times, but out of 100, 95% of the population would be captured in that study, but you always have a 5% outliers. Is that an understanding that is accurate?
Okay, the accurate is that it's conceptualization. Okay, nobody's going to have a data set in front of them and 100 times just sit there and click it. So it's a concept that if I were to do this 100 times,
yes,
the whole purpose of inferential statistics is to take a smaller subset, which is a sample, and be able to confidently say that what I have got from this sample, I can confidently speak that it applies in the broader population.
Right.
What you're saying is that so 95% of the time, that value is going to come between here and here. That's what it means.
That's what it means. Okay.
But it has a lot of different meanings in terms of anyone's particular research now, which I can't give a prescriptive answer.
Sure.
Because small confidence interval could mean something completely different in one research context than another. A small or a large effect size in one research context could mean something completely different than in another. But as long as you understand conceptually, you know, that these are concepts that you need to understand. And when you see them, and when you see them in a rubric, when you see them in an assignment, you have a little bit lower anxiety and you have some kind of comprehension of what you're trying to do and what this stuff means. So then as you start reading, you know, your required readings, it should come a little easier, is what I'm saying.
Thank you. But does that mean that you can change it to 98% confidence interval sometimes too? Because I've seen
you can do that. I believe in one of your applications, you're going to change it to 90% just to see, you know, and understand how that differs based on things such as sample size, things such as changing the confidence interval, et cetera. That's the whole idea of that application, is to understand how these parameters change and impact results. What if I had a larger sample? What if I had a narrower confidence interval? All those are things, but what we're trying to make sure you conceptually now can reason and understand what would happen if this. Now you're thinking, you know, as a scientist now. Okay.
Thank you.
All right. So we're past the hour here. I have to run now. But anyway, I think someone says, will you be able to see the video? Yes, the video will be recorded again. And as I mentioned, you will find the video recording sometime tonight on the YouTube site or sometime tomorrow right here. Right
Dr.
here.
Taylor,
Yes.
what about the previous one? Do you have that already? Huh?
Yes, everything is out at whatever these sites are, previous ones, you mean sessions, everything that's
Yes.
available is at these sites.
Okay. Thank you.
Okay. So let me go ahead and put the presentation here in the chat for you, okay?
Thank
So
you.
give me just a second to do that. And then you guys will have this to refer to. And remember, these will be the links to go to get the recordings, okay? So give me just a second and let me attach the file. To everyone. So now everyone checking the very bottom of the chat now should be the statistical significance, effect size, confidence interval PowerPoint presentation. And you can go into that slideshow to get the links to get out to the other resources. Okay? So we're good to go.
Yes, thank you.
Okay, thank you. And again, please take advantage of that
Thank you.
survey
Yeah.
for me and let me know. And again, the main thing about this Office of Research and Doctoral Services site, again, remember, this is the location where you can see if you don't get a notification via email from whoever or however you find out about these sessions, that out here at the ORD's website, again, and someone mentioned that you have other ones. Here they are, on-demand quantitative seminars, about 25 of them here. Every basic topic, everything you can think of, and I continue to do them live. So the live ones will show up here that will be coming up. You register as you normally did. And for example, tomorrow, this one will move down here to the on-demand and you would click on the recording, okay? So they're all here. Here's
Okay.
one specifically on confidence intervals. It just focuses on confidence intervals only. Descriptives, you know, we've done these before. You guys are going to be coming up on running certain tests, Pearson's product moment correlation test. If for some reason when an announcement comes out and you cannot attend that session, you can always look at this one, or you can always look at the on-demand recording when that one's uploaded. So I'm trying to get you to understand the ecosystem that we're building here so that you know where the resources are and how to get to them. If for some reason, when I send these out to program leadership, if the emails don't get all the way down to you. Does that make sense? Okay. All righty. So everyone have a good evening. Good luck with the confidence intervals and all those things. And again, I hope to be alongside you with all these statistical tests and things that'll be coming up. But again, if not, they are listed here. Okay. So
Okay.
everyone have a great evening. And
Yes, well, bye.
I will see you at the next session. Okay.
Okay. Okay, thanks.
Thank you very much. Okay.
Bye. Thank you.
Bye-bye. You're very welcome.